Good afternoon, students. Can you hear me?
Good afternoon, sir.
Good afternoon, sir.
So let's begin the unit 3. So unit 3 is basically your measures of dispersion. So if I talk about like unit 1 and unit 2, all basics things will be already covered in the unit 1 and 2. Okay. So whatever the extension will be there, like we have seen certain advantage and disadvantage of mean, median, mode. Okay. So we have also seen some advantage, like we can do certain, like we can do more calculation on mean, means we can do mathematical calculation on mean. Okay. So further mean can be utilized, and based on the mean one can able to explore more. Okay. So what actually this measures of central tendency does, the measure of central tendency just give the idea about the central value, which can be mean, median, mode, etc. Okay. But doesn't reveal about the uh, you can say more characteristics about the data. More like central value just tell you like what could be your middle value. That's it. Nothing else about the data. Okay. So that's why there is an requirement of measure of dispersion to explore more or to understand more deeply about the data. We should always go for measure of dispersion. Okay. So to explaining more about the data, let us consider one very simple example. For example, let's say I have a 3 sets of data. Okay. Let me consider 3 sets of data. For example, we have a set 1. Okay. We have a set 1. In set 1, I have a data, let's say 4, or I will just consider some 3, 2, 9, 1, 0, some data. Similarly, let's consider set 2 data, which is 7, 8, 0, 5, 0. Similarly, set, I can say another set. So what could be that? Let's say set 3. So what could be mean of this? 15, 15, 15 by 5. So it is 5. If I consider this set as data set 3, 3, 3. So let's see what will be mean of this. Just calculate the mean of this. What could be mean of this one? So this is 10,
3.
3. What about mean of this? Is it
4.
4?
Yes, sir.
Okay, so you try to make it 3. So to make it 3, let's say to make this is 15, right? So for 15, we just consider this is 2. Let's say this is 3. Okay, so it's become 15, correct? So 15 by 3, it's become 3. And similarly, when you calculate the mean for this, we'll get 3. Okay, so just try to understand how this particular things works. In data set A, or I can say data set 1, 2, 3, I have 3 data sets. If I'm just trying to calculate the central value, maybe the mean, maybe median, maybe mode, something like whatever central tendency is based on that. You may find this all this set having the same mean. All these set having the same mean. So how do you understand which set is like better? If I compare set 1 and set 2, I got the mean is 3, and here is also mean is 3. So how do you know about which set will be better? Similarly, if I compare set 2, set 3, how do you know the set whether which set is better? So because of the based on the central tendency, we are finding that whether which set will be better. But in this scenario, you can understand if I'm using the I can say technique of central tendency like mean and calculated that, we found that all this set having the same mean. So I may not able to conclude that whether which set will be better. So for that purpose, we need to check for their variability. We need to check for their dispersion. So whether I say variability or whether I say dispersion, both the meaning is same. So if I just represent in a form of pictorial, so if I look at this graph, you may find 3 will be here somewhere. Okay, 2 will be here, 9 will be here, 1 will be here, 0 will be here. So the graph will be look like this. Okay. Similarly, if I look at the next set B, I will say some point, let's say mean will be here, and my some value will be here, some value will be here, some will 3, 2, 00, like that. Are you getting my point? So again, you can see that set 2 is also little bit, I can say, away from the mean. This is my x bar. This is my x bar, which is 3. Similarly, if I look at set 3, I will find that my x bar is 3 and all observation is also 3. All observation is also 3. Are you getting the point? So this is basically, I can say that in this data set, there will be only one point. That means the deviation between this and this is 0. Similarly, deviation between this observation, deviation means difference. Deviation means difference. So 3 minus 3 is 0. Everywhere you can find the deviation is approximate 0. That means the difference. That means I can say that in my data set 3, if I am using further, I can say knowledge about my data sets 3, I can able to conclude that variation among the data from the mean is very less, is very less. Similarly, concluding about this two, set 1, set 2 is quite difficult until we will not able to obtain the variability among the data. Variability among the data. Okay, so this is something like we are not understanding more about the data. So until unless you apply the unit 3 knowledge, measure of dispersion, measure of variability, you may not get the more additional information about the which set will be the better, means more dealing with about the data. Okay, so I can say that more variability in the data, that means there will be more dispersion, right? So if there is a more dispersion, means there is more, I can say, when you calculate the variance and if it is more, then I can say that more variability in data. More variability in the data, that means that I can say it is less consistent. Consistency is very less. So the variability is very high. So that means that your data is very less consistent. Means it has, like, I can say that data will be not appropriate doing further analysis. Okay, so this is all basics about how these dispersions are, I can say, useful. Okay. So I can, with this, I can just conclude that. Uh, so I hope you understood a little bit conceptual knowledge of dispersion and how that works. That we will see mathematically maybe in the coming session. Okay, but broadly, I will conclude that uh, here, if you just look at this central tendency, that is the mean, okay, it fails. Means the mean failed. Okay, so that's why now we'll go to the measure of dispersion. So हम लोग variance calculate करेंगे for all the sets and then try to see that which set having less variance, and based on that we will select that set and we can conclude that variability among the set 3 or set 2 or set 1 is appropriate or is less. That's why set 3 or set 2 set 1 will be better as compared to another set. Okay, so this is like all basics you can try to understand, but few things I just want to put in the point. Okay, so that maybe I can say some point like when dispersion is less, when the dispersion is less, that means when variability is less, the average, average means mean, is more reliable to more reliable, so that so that it is better estimate of the population average. It is better estimate of the population average. Okay, so if the dispersion is less, okay, so the average which you have calculated like this x bar, this will be, I can say that, more reliable, means more correct, I can say. And what it represents, that means it is the better estimate of a population average. The population means you have already seen what is the population mu, right? And another thing, it is just opposite. When it is more, then the average will be less reliable, so that it is not better estimate of, it is, I can say, not good estimate of population. It is not good representative of data, or I can say estimate of the, both the meaning is same. It is not a good estimate or representative of. Okay. So mainly it is important that your dispersion should be less. Okay, very important. Try to get the dispersion is less. That one thing. Second, I can put another points. Less dispersion implies that more consistent data. Less dispersion implies data is more consistent. Similarly, more dispersion implies that less consistent. Okay. Now you can understand, dealing with all this, I can sense in terms of statement, might be you will not understand more knowledge about the variability. But just try to understand, that means I'm talking about my scatterness. I'm talking about here, I'm talking about scatterness. Or I can say variability. Okay. So that is all meaning of your. But if I talk about terms of mathematically, this entire dispersion is split into two parts. One will be two categories. The first one, I can say absolute measures, and second one, relative measures. Okay. In absolute measures, we have a certain technique, as I can say that you know that when we have a mathematical average, mean is called as a mathematical average. Okay. Similarly, median and mode is called positional average, right? Similarly, when you have to calculate the absolute measures, what are the technique we have? We have a range, we have a I can say a QD, which is called as a quartile deviation, quartile deviation. Sometimes it is also known as SRIQ, semi-interquartile range. Semi-interquartile range. This QD, semi-interquartile range. Then we have a MD, which is called as a mean deviation. And lastly, we have a standard deviation. I'll put first so SD, which is called standard deviation. Similarly, in the case of relative measures of range. Relative measures means when this absolute measures fails, not absolute measure. Absolute measure is a technique. Among that, if the range is fails, then we will try to calculate their coefficient of range. That is the absolute measures. Okay. So in this case, we have a coefficient of range. Similarly, in this case, we have a coefficient of QD, means quartile deviation. Similarly, we have a coefficient of MD. Similarly, the last point, we have a coefficient of variation. Okay. So we have a total 4 plus 4, total 8 techniques to understand more, I can say, more idea about the variation. But the only question is that when do we apply this absolute measures and when do we apply these relative measures? That is the very, very important part. That is a part of the our descriptive statistics. That's actually you can call application of statistics. Otherwise, calculating this range and everything will be quite easy. Means everyone can able to calculate very simple. So when I talk about the absolute measures of a dispersion have a same unit as that of the data observation. So if we talk about, let's say, height of all the students. So if you just look at the height of all the students, it is units are same. Units are same. If I talk about income, so income is going to be always in form of rupees, not in pounds. So if data observation having the same unit, data observation having the same unit, I may use always absolute measures. I may use always absolute measure. So this is having same unit. And opposite of that, that means we are going to use the relative measures. There are several examples, but I'm not putting more about that. For example, suppose we have a group of the person and the variation in the height and the variation in the weight is to be compared. We want to compare the height of that person with the weight of the person. So you can see here, I cannot use absolute measures because the units are different. So if the units are different, I may not use absolute measure. Absolute measures totally fails. I have to use always a relative measures. Okay. So remember, so whenever you do not have the same units, you can always go for relative measures. That is all basics. Okay. That is all basics. And I can just put one thing like relative measures is the called as coefficient of relative absolute measures, therefore it is unitless quantity. Means whenever you calculate the coefficient of range, right, we don't have any units here, it is unitless. So this is the unitless which is important. Okay, this is the unitless. So in this case we have to be write the unit because it has the same unit, but in this case whenever you calculate the coefficient of range, quartile or MD, you should write without unit because it is the unit less. Because you're comparing the like a kilogram with the, I can say, in centimeter. So it is not possible. It is not possible. Getting me? Hello, can you hear me? Students, can you hear me?
Yes, sir.
Yes, sir, but not clear.
Sorry. Maybe some connectivity issue is there, but I'm trying to connecting again and again. Okay, I'm just sharing the
Yes,
screen.
sir.
So let me know if I'm not audible. So you can just put the message on in the chat box. So the two things very important when you talk about the same unit. That means I'm going to use absolute measures. Otherwise, I'm going to use relative measures. Relative measures are basically used when we do not have the same units. I can say that it has unit which is unitless quantity. Okay. See, there are several things. Okay. So that you can consider for like you can refer any different reference book for that. Okay. So let us discuss one by one. Let us discuss one by one, like all these methods. Okay. So the first one we start absolute measures. So in absolute measures, we have the first one. The first one is called basically range. Okay. So you know what is the meaning of range? Range means generally you call ना मेरा range नहीं है mobile का, right? You can, so it has a limit. Range means it has a limit. It has a smallest limit. It has a largest limit. It has a smallest limit and it has the largest limit. So what is an application of the range? You may find, you may surprise when you like do any kind of like checkup, body checkup, maybe cholesterol level, maybe hemoglobin level. Okay, so you, there is always some lower limit and there is some upper limit. So when like hemoglobin lies between, let's say it is 8 to 12. So if the below that and above that, it will create a problem in our body system. Okay, so this range, if I talk about the range, so range is also a very important factor in, I can say, in the real life situation. Okay, maybe you have found that like in some of the resort, how this range is very good, like they are using their applications. So you may find like in swimming pool, the depth of that water, they put one line, like below that you should not go because it's very deep. That means the range they have measured, and based on the range concepts, they have made that line. So from where, I mean, how do you know whether the line should be here and there? Okay, so using the concepts of range, like the minimum value and the maximum value, they have considered the height of that water level, and based on that they are putting that line. Okay, beyond this, like if the age of let's say 12, 13, 14, if the person age is 12, 13, 14, you should not go beyond of this line. So because of they know this particular range, and they always use this concepts of range. So what is the range? Range is, I can say, uh, so if let's put the statement, it is difference of largest number, or I can say instead of number, I will say observation. I will just say observation. Largest observation and smallest observation. Okay. So largest observation, I will just call this is L. This is I will call S. Okay. Therefore, so I have already mentioned it is the difference between the largest number and smallest number. Therefore, it is denoted by capital R, which is equal to largest minus smallest. So it's a difference of largest number minus smallest. Okay. So I can you can just understand how this particular things works. So it's very simple. You may have to select the largest number from the data. You have to select the smallest number from the data, subtract, and you can get the values of range. But you can understand, there are some problem with this range. There are some problem with this range. What is the problem? It doesn't give more about average value. It doesn't give more about the average value. Average you understood, central value. Because here we are only considering the smallest number and the largest number, means upper number and lower number. right? So it gives only information about the two observations, not like entire observations. So I can say if the mean is not appropriate method, then absolute measures under the range is like it is not much useful. Okay, so one can able to get coefficient of range. So what could be coefficient of range? Coefficient of range. So instead of writing this heading for absolute, I will just take combine, so that this is not deviation, this is deviation. Deviation. So the next definition, the coefficient of range. So what is the coefficient of range does? The coefficient of range is basically used for the relative measure. So when this method fails, the range concepts fails, I can use coefficient of range, which is equal to L minus S upon L plus S. Okay. So coefficient of range, I can say obtained, it's a ratio of range upon least number plus largest number. Okay. And there are certain, I can say, note on that. What is a note? I usually more focus on the note part. Why? Because these notes are very important. Notes are, na, note means what? Money. Money is very important, right? So if you just look at this note part, range is only used when you have a small data. When you have a very large data, it's very difficult to get the smallest number and the largest number from the data. अगर आपको 50 observations दिया, and I will tell you, can you find the minimum value and maximum value from the data? It is very tedious for us, right? So it is suitable for small data. It is suitable for small data. It is suitable for small data. And what is the next drawback here? We are considering, as I mentioned, we are considering the extreme values. We're considering the extreme values. For example, imagine in your data set, some observations maybe, let's say 10, 20, 10, 20 like that. And one observation suddenly it is 200. So maximum is 200 and minimum is 10. So can you understand? So whenever this situation is happen, you can understand range fails. Range fails. So this is the one of the, I can say, very important drawback of range. Why it fails? Because if I have a something called outlier in my data, which is very small and which is very large, and I'm just ignoring the rest observation, then that data will be not appropriate for doing further analysis. Okay, because of in my data content, I can say extreme values. Okay, so what is the second note says? The main drawback, the main drawback of this measure is that it is based on only two extreme values, that is maximum and minimum value. and completely ignores all the remaining observations. Remaining observations. This two note which is always you take care in the case of range and coefficient of. So let us take one example. Let us take one example to understand. I can say more. I hope you cleared the theory concepts of that more range. So let's take that. So let's take example number 1. Find. I think example you can take down. Find the range and coefficient of range of weights of weights of 7 students from the following data. You can take down the weights. What are the weights? Let's say these are the weights. Try to calculate using above examples and let me know the answers for that. These are the weights which is given in kg. So use concepts of. So what is your largest number here? Can you tell me, anyone? Largest means bigger number.
53,
53. What is the smallest number?
37.
37. So based on this, you can use calculator and you can find range. So range is equal to R, which is
16.
yes, S, L minus S, which is I can say 53 minus 37, which is going to be 16 kgs. Similarly, you can find coefficient of range. Which is L minus S upon L plus S, which is same as 53 minus 37 upon 53 plus 37. You can just do the calculation. This is 16 upon 0.90.
90.
How much it is?
0.1.
0.177.
0.177.
0.
2.
1778.
Hmm?
1778.
Correct.
1778. So, but you can see here I am not writing any unit here because it is unitless. It is since here we have a same data, like we have a same unit kgs, okay. But still I'm not writing because coefficient of range is something like we have written theory. According to theory, it is unitless. Okay, so you can go without unit. Any question so far till here? Any question? Anyone? I didn't check the chat box. See if having any questions. Yes, correct. Any question?
No, sir.
Okay, let's go ahead. So the next part is, which I just want to discuss. It will not take more than 2 minutes for me. because that is already we have seen in the previous classes, which is called quartile deviation, called as quartile deviation. Quartile deviation, I can call bracket में QD, or I can call semi interquartile quartile semi interquartile range. Okay, SIQR. So both the meaning is same. Okay, so quartile deviation is what? It's a difference of, so it is difference of largest largest quartile. Largest quartile means Q3 and smallest quartile, which is Q1, which is Q1. Therefore, it is denoted by QD. Short form we can use QD, which is Q3 minus Q1. Just a minute, I forget to write. It will be not semi. What I have written here. So it will be simply divided by. So it's not actually difference. I can call the half definition. It is the half definition. Okay. So let me define first IQR. Okay. Let me define first IQR. This is the IQR. I think just a minute, give me time. It is IQR. What is IQR? IQR. Remember, this is I have written what? SIQR. What is IQR? Interquartile range. Interquartile range is defined. See, as you define quartile range, as you define range, what is the range? Smallest minus largest. Sorry, largest minus smallest. So when you talk about interquartile, that means I'm talking about the quartile. So what is a quartile? Quartile is nothing but it's a difference of the largest quartile and smallest quartile. Okay. Therefore, I can define interquartile range. What is interquartile range? It is going to be IQR, which is equal to Q3 minus Q1. Okay. So once I know IQR, I can define SIQR, which is semi-interquartile range, which is Q3 minus Q1 upon 2, and this is also equal to quartile deviation. Right. And similarly, the corresponding relative measure of dispersion is called is called coefficient of quartile deviation. Quartile deviation. And is defined as and is defined as and is defined as coefficient of QD equal to Q3 minus Q1 upon Q3 plus Q1. Okay, so you can again try to understand the concepts of quartile deviation. And as I mentioned, I'm talking about the quartile concepts. So you know that quartiles are basically independent of extreme values, right? So if in our data, if we have a outlier, or I can say very small number or very big number, then it doesn't taking consideration under the quartile, because quartile means your data is divided into the 4 part and we're considering always the middle value. Okay, so I can say one of the advantage, instead of using range, one can use quartile deviation. Okay? And there are so many advantages that we will hopefully we will discuss in the next class, but you can visualize that the unit 2 that we have studied the concepts of all quartiles, we are again going to use that same examples here. Okay, so it is not possible to do me like, because it is the same type, so you can, so we'll refer that example number 10, example number 13, example number 14 from unit 2, and that value will be directly considered here, and we can able to solve the problem based on that. Okay. So that we will see in the next class. I think sir has already joined, so I'll just make them host. Yes, Ankit sir, good afternoon. You're there? So see you students. So we will solve the problem based on the quartiles maybe in the next session. Okay.
Okay, sir.